Hey everyone, welcome back. This is lesson 11.1, Permutations and Computations. Your objectives for this lesson: by the end of this lesson, you're going to be able to solve problems involving the fundamental counting principle, and you'll also be able to solve problems involving permutations and combinations. Your vocabulary for today: fundamental counting principle, permutation, factorial, and combination. You have previously used tree diagrams to find the number of possible combinations of a group of objects. In this lesson, you will learn to use the fundamental counting principle. So here is the fundamental counting principle. If there are n items and m1 ways to choose a first item, m2 ways to choose a second item, after the first item has been chosen, and so on, then there are m1 times m2 times m so on down to m sub n ways to choose n items. So let's put that into real practice now. Let's look at this example using the fundamental counting principle. To make a yogurt parfait, you choose one flavor of yogurt, one fruit topping, and one nut topping. The question asks, how many parfait choices are there? Well, let's take a look at our menu. We have plain vanilla. We're going to have 2 choices. For our fruits, we have 5 choices, and our nuts, we have 3 choices. So we're just going to multiply those all together. Our 2 choices times 5 times 3, and that equals 30. So that tells us there are 30 parfait choices. Here's another example. A password for a site consists of 4 digits followed by 2 letters. The letters A and Z are not used, and each digit or letter may be used more than once. How many unique passwords are possible? So we have 4 digits, and each of those digits is going to have 10 choices. And then the letters, since we can't use A or Z, we're going to have 24 choices for each of those. So when we multiply all of those choices together, we end up with 5,760,000 possible passwords. Okay, so try this one on your own. Turn your video off and give it a try. Okay, that's not too hard. A make your own adventure story lets you choose 6 starting points, gives 4 plot choices, and then has 5 possible endings. How many adventures are there? Well, we see that we have the number of starting points. We have 6, 4 plots, and 5 endings. Multiply all those together, and we get 120 different adventures. Again, try this one on your own. Turn your video off and give it a try. All right, this problem says a password is 4 letters followed by 1 digit. Uppercase letters and lowercase letters may be used and are considered different. How many passwords are possible? So we're going to have 4 letters, and so since both uppercase and lowercase letters can be used, there are actually 52 different possible letter choices. So we have letter choices and then a number digit. So we have 10 number choices and 52 of the letters. When we multiply that together, we get 73,116,160 possible passwords. All right, a permutation is a selection of a group of objects in which order is important. All right, so important is a permutation. All right, so for example, there is one way to arrange one item A. So there's no choice there. It's just one permutation. There's nothing changing. A can only be in position A. All right, if I have a second item, now I can have 2 permutations. I can either have BA or AB. So a second item B can be placed first or second. And then finally, for a third permutation, item C could be added. So you could have CBA or BCA or BAC. You have 3 different choices, and so it's going to be 3 times 2 times 1. It would be your permutation. All right, you can see that the number of permutations of 3 items is 3 times 2 times 1. You can extend this to permutations of n items, which is n times, and then here's n minus 1, n minus 2, n minus 3, and so on. So I just want to point out when we're doing that, this is if 3, which would be n minus 1, 3 minus 1 would be 2, 2 minus 1 would be 1. That's where we get this minus, okay? So, and keep on going. The expression is called n factorial and is written n with an exclamation point. Next. Here it is written in words first. The factorial of a number is the product of the natural numbers less than or equal to the number. 0 factorial is defined as 1, which I find is kind of interesting because 0 times 1 is 1, but we're not going to go there right now. Okay, so you may want to turn the video off right now and make a copy of this. This is a pretty important thing that you need to know. So, for example, in numbers, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, which is 720. And then there it is written algebraically. Sometimes you may not want to order an entire set of items. Suppose that you want to select and order 3 people from a group of 7. One way to find possible permutations is to use the fundamental counting principle. So let's see what that means. So there are 7 people and you are choosing 3 of them in order. Let's say I want to choose a president, a vice president, and a secretary. Okay, so let's see. The first person is going to be my president, and I have 7 people to choose from. So I'm going to have 7 choices. Now that I've chosen a president, I need to choose my vice president, my second person. So now that my president's been chosen, I only have 6 choices. Finally, I'm going to choose my third person, and that person will be my secretary. And now, instead of 6 choices, I only have 5 choices left. So now, using the fundamental counting principle, I can just multiply those together. And when I multiply them all together, I end up with 210 permutations. Another way to find the possible permutations is to use factorials. You can divide the total number of arrangements by the number of arrangements that are not used. In the previous slide, there are 7 total people and 4 whose arrangements do not matter. So as you can see, the arrangements of 7 divided by the arrangements of 4 is equal to the same as 7 factorial divided by 4 factorial. And when we work it out, we can see that the 4s will cancel, the 3s will cancel, 2s and the 1s will all cancel. And then when we multiply it all out, we get 210. So this can be generalized as a formula, which is useful for large numbers of items, because this was just 7 and 4, which is pretty easy, but when you get to larger numbers, we need to have a general formula. So here is the generalized formula. Remember, permutations are for when order is important. All right. So in numbers, the number of permutations of 7 items taken 3 at a time is written like this. N P sub 3 is equal to 7 factorial over 7 minus 3 factorial. In other words, 7 factorial over 4 factorial. And here it's written out also in algebra. Again, you may want to turn your video off and take note of this. This will be important for you to remember. Let's do an example. How many ways can a student government select a president, vice president, secretary, and a treasurer from a group of 6 people? So again, this is equivalent of selecting and arranging 4 items from 6. So we're going to substitute 6 for our N. Here's our formula, and 4 for R. And now the rest of it's pretty easy. It's written 6 factorial over 2 factorial. And when we divide out the common factors, we end up with 6 times 5 times 4 times 3. And so there are actually 360 different ways to order this group for our student government. Okay, so here's another one. How many ways can a stylist arrange 5 of 8 vases from left to right in a store display? All right, so we have 8 vases to choose from, but we're only worried about 5 of them. So again, here we set it up, 8 factorial divided by 3, because 3 of them we're not going to use. So it's just 8 divided by 3 will give us our 5. Divide out the common factors then. And once we do that, we see that we have 6,720 different ways to arrange 5 out of 8 vases from left to right. All right, here's a little bit different one. Turn your video off again and try it. All right, so awards are given out at a costume party. How many ways can most creative, silliest, and best costume be awarded to 8 contestants if no one gets more than 1 award? So think about it for a minute, and we see that we have 8 contestants, and 5 of them are not going to get an award at all. So we're only giving out 3. So 8 factorial divided by 5 factorial. Once we cross out the ones that cancel out, we have 8 times 7 times 6. So that tells us that there are 336 ways to arrange the awards. Okay, try another one on your own. Turn your video off and give it a try. All right, so this one says, how many ways can a 2-digit number be formed by using only the digits 5 through 9 and by each digit being used only once? All right, so that tells us that we have 5 choices, 5, 6, 7, 8, 9, and we only need 2 of them. So 3 of them aren't going to be needed, so we can cancel those out. So in the end, 5 times 4 is 20, and so there are 20 ways for the numbers to be formed. A combination is a grouping of items in which order does not matter. There are generally fewer ways to select items when order does not matter. For example, there are 6 ways to order 3 items. So I have 3 items, A, B, and C, and I can have it, if order does matter, I could have it ABC or ACB or BAC, 6 different ways. So I have 6 permutations. But if order doesn't matter, then I really just have one combination, ABC. It doesn't matter what order they're in, I just have one combination. To find the number of combinations, the formula for permutations can be modified. So you'll probably want to turn your video off to take note of these. So the number of permutations, which we've done already, is the ways to arrange all items divided by the ways to arrange items not selected. Now, because order does not matter, divide the number of permutations by the number of ways to arrange the selected items. So for the number of combinations, we're going to have the ways to arrange all the items, and that's going to be divided by the ways to arrange the selective items times the ways to arrange the items not selected. So here is your generalized formula for combinations. So we want to take the number of combinations of 7 items taken 3 at a time. And it's written like this. So you're going to say 7 factorial over 3 factorial, because that's how many you're going to take, and then multiply that by the number of that you're not going to use, 7 minus 3. So, and there it is written out algebraically, and we're going to do some problems with it now. When deciding whether to use permutations or combinations, first decide whether order is important. Use a permutation if order matters, and a combination if order does not matter. And I, for some reason, just can remember permutation important. Okay, important. So I remember that P, important. Okay, if order is important, it's a permutation. Okay, if it's not important, combination. And then you'll need to choose which formula to use. So, helpful hint. This is really helpful hint. You can find permutations and combinations by using NPR for permutations and NCR for combinations. And that's just the formula that we've been looking at in our past slides. All right, so we're going to try an application, example 3. There are 12 different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? So first of all, we need to decide, are we going to do combination or permutation? Does order matter? Well, I say the order does not matter. The cubes may be drawn in any order. It is a combination. So that's how we choose. We just think about what's happening. Does it matter what happens, or I'm just going to choose 4 and it doesn't matter? All right, so now that we know that formula for combinations, we know the n is 12. There's 12 in all, and I'm going to choose 4. So I can put it into my formula, 12C4, and then just multiply it out and divide out the common factors. And once you do that, those all cancel out, and I end up with 495. So there are 495 ways to draw 4 cubes from 12. You could also put this in your calculator. All right, try example 3 on your own. Turn the video off and give it a try. All right, so in this problem, it says the swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? Well, does order matter? Is it important? No, so we're going to do combinations. So in order to do combinations, let's decide that our n is going to be 8 and our r is 2 because we're only selecting 2. We have 8 and we're going to choose 2. So the formula for combinations is as follows. Just divide out the common factors. We end up with this. We can cancel out 2 and 8. It leaves us with 4. 4 times 7 is 28. So the swimmers can be selected in 28 ways. All right, and that is the end of your lesson, but here's a little short quiz for you to try, so you can turn your video off one more time and give these a try. All right, so I'm not going to go through these right now with you, but if you did it, here are the answers. 720, number 2, 80,000, number 3 is 720, and number 4 is 455. So make sure you understand the difference between combinations and permutations. Permutation is when order is important. All right, so keep that in mind. And that is the end of our lesson for today, and I will see you in class. Have a great day. Bye.